Hello guys, so far we have finished talking about disturbances in rock layers and what happens when there's missing evidence. Now today we are going to take it a step further and talk about something called absolute dating and radioactive decay. Now, absolute dating is the process of establishing the age of an object. And what happens is that with the help of this process, geologists and scientists try to determine the number of years that particular object has existed so far in our world. So, if you had to define absolute dating, it would be a method of measuring the age of an event or an object in years. And that's absolute dating. Now, we have specific types of absolute dating. One of which is radiometric dating. And we will learn more about this in detail tomorrow. But let's try to understand what radioactive decay is before we start. So, as you can see in this image here, we can see that there is an unstable isotope. It has 6 protons and 8 neutrons. And then it leads to radioactive decay. So the reason why it leads to a radioactive decay is because there is some unstable isotope. And when there's an unstable isotope that decays, a neutron gets converted into a proton. In this process, an electron gets released. Now, if you look over here in this picture, you can see that there is an unstable isotope decay, and the neutron is getting converted into a proton. And when this process is happening, you can see over here through this brown particle that is escaping this element, that is a electron that is being released. And when the electron is released, it gets converted into a stable isotope with 7 protons and 7 neutrons. So initially it had 6 protons and 8 neutrons, and one of the neutrons gets converted, and in the middle of which an electron is released, and that results to something stable, which is a stable isotope with 7 protons and 7 neutrons. Again, this is an example. It can differ. Now, if you were questioning what an isotope exactly is, an isotope is the atom of an element that have the same number of protons but different number of neutrons. Um, those are isotopes. So again, if you look to the left, there is a clear definition here that says the same number of protons, but if there's a different number of neutrons, that is what is known as an isotope. What is radioactive decay then? Now, to determine the absolute ages of rocks and fossils, scientists actually analyze the isotopes of radioactive elements. Now, there obviously are different types of radioactive elements. Now, atoms of the same elements with the same number of protons and different number of neutrons as isotopes, most of them are stable, meaning that they remain in their original form. But there are some isotopes that are very unstable, and scientists call unstable isotopes as radioactive. And when radioactive isotopes break down, they break down into stable isotopes of the same or other elements, and this process is known as radioactive decay. So, this process of it breaking down to become something stable is known as radioactive decay. And this is a good example of how it occurs. And because radioactive decay occurs at a steady rate, scientists can actually use the relative amounts of stable and unstable isotopes present in an object to determine the object's age. So if they're studying an object which shows radioactive decay, we know that it's happening at a very stable rate. So this can be actually used to measure its age in terms of years. And that's what we're going to learn today. I hope you guys have a great day. Again, if you have any questions, please feel free to contact me. And I will see you later. Bye.